Good morning, students. Today we are going to discuss the first lesson in IGCSE 91 Physics syllabus, Unit 1 Forces and Motion. Right. First, we'll divide this unit into three parts. We are going to learn units in Part A, Part B movement and position, Part C forces, movement, shape and momentum. Now we'll come to the unit Part A, units, right? We'll discuss units in this video. Okay. Uh, First of all, we'll check intended learning outcomes, ILO, of this lesson. 1.1. Use the following units: kilogram, meter, meter second squared, Newton second and Newton kilogram. Here, this is according to a specification. You can see this bold sentence 1.2p, it coming with p. So this type of content is only coming in paper 2. You have paper 1 and paper 2. So bold content in specification, it comes in only in paper 2. But this normal font use the following units. That's 1.1. It's not having p like this one, right? So this content, it is coming in paper 1, paper 2 both. Okay, remember that. Now we'll move to the lesson. What is unit, right? So physicists, like other scientists, make observations, and they ask basic questions, right? So how big is an object, how much mass does it have, how far did it travel, right? So to answer these questions, they make measurements with various instruments. For example, if you take meter ruler, balance, stopwatch. So when you take a measurement, right, you need to identify this measurement separately. For that purpose, we need units. We need units. The measurements of physical quantities are expressed in terms of units, which are standardized values. For example, the length of a race, which is a physical quantity, right? It can be expressed in meters or kilometers, right? So without standardized units, it would be extremely difficult. Previously there were different units, right? Various units. Some of them we call imperial units, right? So these units are not used in the syllabus. For example, earlier we use uh, still we are using inch, right? Foot, yard, mile, still we are using this, but in this Edexel IGCSE syllabus we don't use this type of units. For length we use what? Meters. Mass, there are different unit: ounce, pound, stone, right? Here in this syllabus we are using kilograms, grams, milligrams, tons, right? Those type of units. Capacity, pint, gallon, we don't use these imperial units. We use what? Cubic meters, liters, milliliters, right? Like that, we use those type of units. So still some countries using these unit, imperial units: USA, Liberia, Myanmar. These three countries still using imperial units. So what are the units we are using in this syllabus? We are using SI units. So what is SI, right? SI means uh, Standard International Unit. So this is internationally recognized unit system, or we call them base units. Base units. We can call SI unit, another term base units. So there are 7 fundamental base units, or there are 7 SI units in physics. What are the SI units? You can write meters, right? Then kilograms for mass, meters for length, seconds for time, right? Kelvin for temperature, right? We don't use degrees Celsius as a SI base unit. we use Kelvin, right? Then in chemistry you have learned mole for amount of matters, right? Then we use candela. We don't use this unit in this syllabus, right? Candela, simple C, simple D. Light intensity is measured using candela. Another unit, amperes. Amperes, you know, we use this unit to measure current. In electricity lesson, we'll learn that. So we'll again check these units. Meters for length or distance displacement, kilogram for mass, time seconds, temperature Kelvin, amount of matter mole, light intensity, candela, current ampere. So SI base units, 7 of them are here. They are known as International System of Units, or we call it SI units, right? But in this lesson, right, forces and motion lesson, we mainly focus on three units, three SI based units: meters to measure lengths or distances, kilogram to measure mass, seconds to measure time. Okay, so these are the instrument we are using to measure SI base unit. So sometimes this SI base unit system, we call it metric system. SI units are included in the metric system and some other units are there, right? We'll check that later. So you can see here in this slide, I'm showing what are the instrument we are using to measure these base unit: mass, kilogram. We can use a balance, right? Here force, Newton, we can use what? A force meter or Newton meter. We call it force meter. Time, we can use a stopwatch, right? So there are some units called SI derived units. SI derived units, right? That means these are derived from SI base unit. These units are derived from SI base units. For example, right, if you take unit of volume, volume is created by meter into meter into meter. So cubic meter, but you can see meter is SI unit, right? So another example, unit of force, Newton, we use single unit, it is a name of a scientist. We can use kilogram meters per second square. Unit of speed, meters per second. All these single units in the derived units are SI units. So these are created using SI units, right? Now other accepted units, these are non-SI units, but it is accepted for the use with the SI unit. Here this is accepted by CIPM, International Committee of Weight and Measures, right? uh, Here minutes, hours, days, so we use these units even they are not SI units, we are using them with the SI unit system. So altogether these non-SI units, derived units and SI units, we call them metric system. Metric system. So in this syllabus we are using metric system, right? So you can see degree, and when you measure small, very small angle, minute, very small angle, second, then hectare, liter, metric ton, these units are non-SI unit, but we use in the metric system. Now we will come to very important topic, rules and conventions for writing base units and their symbols. So there are some rules, you should follow these rules when you writing SI base units or derived units with the measurement. First rule, the units named after scientists are not written with capital initial letters. Okay, this is a very common mistake all of you are doing, most of you are doing. You write Newton. Newton is the unit of force. You start that with capital N. If you start that with capital N, now here what? Capital W, that is wrong, right? when you're writing a unit, right? Suppose it is a name of a scientist, even it is a noun, if even it is a name, in this unit system we use simple n for that. Here words capital, not capital W, simple W, lowercase letters. If you use uppercase letters, then it is wrong. That is the first rule in uh, SI unit, writing SI units. We come to second rule. The symbols of the units named after scientists should be written by capital letters. That is very famous rule. We know that if the unit is named after the scientist, it is always capital. So capital N for Newton, capital W for Watts, right? So if you write capital N for Newton, here this N is wrong. You had to write simple N, Newton. That's why I put it wrong there. W here, watts, watt, right? Like that. So second rule is very easy to remember. If the uh, unit is named after a scientist name, you have to write it with capital letter or uppercase letter. Third rule, lowercase letters are used as symbols for units not derived from a proper name. So that is also very famous one. We already know a meter is not a name of a scientist or not a name of a person, right? Kilogram, right? Kg. Here if you use capital M, that is wrong. It's a very silly mistake if you use capital M or capital Kg, right? Capital K and G. Here I'll teach this mistake you are doing. We use capital K and simple G, right? Remember, right, capital K is used in computer science. Sometimes we use capital K to name kilobytes, right? So kilobytes, like that, KB. But in science, right, we use simple K for kilo. Kilo is a prefix and it represents 10 to the power 3. So kilogram is written as simple K and simple G. That is very common mistake most of the students are doing, writing capital K with kilogram, right? When you write some value, some size in computer science, kilobyte, kilo, uh, kilobyte, right? Then capital K is okay, because in computer science kilo mean 1024 bytes. Kilobyte, 1 kilobyte mean 1024 bytes. So to identify that, computer science we use capital K, but in science or physics we use simple K, lowercase k. It represents a prefix that is with a value 10 to the power 3, 1000 times. Kilo mean 1000 times, right? We'll come to the fourth rule. No full stop or other punctuation marks should be used within or at the end of the symbol unless at the end of the sentence. Okay, if it is not uh, an end of a sentence, we shouldn't use this punctuation mark. For example, if you have to write force is equal 25 Newton, we don't put a full stop there, right? We don't put comma or anything. That is wrong, right? If you put a full stop, it's wrong. If you have to write 25 Newton, you write 25 Newton. That's it, right? So that is very easy to remember. No full stop or comma unless it is an end of a sentence. Okay, this is the fifth rule. The symbols of the units do not take plural form. For example, 10 kilogram, not 10 kilograms. So we don't write S at the end. There are no plural forms when you writing units, right? For example, if you write 285 newtons, if you put S, that is completely wrong, because in physics simple S means second. So this will uh, represented as Newton seconds, something different, right? So remember, we don't use plural in physics. Grammatically, maybe it is correct in English, but when you writing units, remember not to put s there. That is wrong, right? Because s is also a symbol we use for time. We measure time. SI unit of time is seconds. So don't use plurals. We just write singular. That means just the unit 10 kilogram. That's it. 10 kilograms. Remember that rule, right? Sixth rule: use solidus is recommended only for indicating division of one letter unit symbol by another unit symbol. Not more than one solidus is used. That means solidus means this line, right? So meters per second, you can write like this, or you can write it as a power of s minus 1, right? Meters per second. Both ways, this is correct. Suppose uh, you have meters per second squared, right? If you write this same thing, meters per second, right? In words it's correct, but when you're writing with two solidus, it's wrong, right? We can only use one solidus. Meters per second. Per second is the correct way to pronounce that, but here when you're writing, if you use a two solidus, it is wrong. You can use two solidus if parentheses are used. Parentheses mean brackets, right? Meters per second. Now it is okay, right? So it's better to remember we can't use two solidus when you're writing units. Only one, right? Here, for example, this one, joules per coulomb mole. So it represent, it's joules per coulomb per mole, right? So you don't need two solidus to write that joules over coulomb over mole. That is completely wrong. Okay, now we'll go to the seventh rule, last one. Okay, here you can see some space is always to be left between the number and the symbol of the unit, and also between the symbols for compound units such as force, momentum, etc. So this is very important rule. When you're writing a measurement, for example, we write 2.3 meters. If you write this without a space, this there should be a space in between meters and 2.3. If you write it like this, that is wrong. So how to write it correctly? 2.3 small space meters, right? 25 small space newtons, right? 184 kilograms, right? There is a small space. And when you writing compound units, for example, meters per second, if you write like this, that is also wrong. So if there are two units, there should be a gap. Meters per second. Meters per second, there should be a gap. Kilogram, meters per second, right? There should be a gap. If you write it like kilogram meters per second without spaces, that is completely wrong, right? And remember why this is important. When you learn prefix, right, you will understand that. Suppose you have meters second. If you write like this, it represent milliseconds, not meter second, right? Suppose you have a unit called meter second, right? Meter second you have to write with a space, then only you can understand this is meters second. Otherwise it is representing millisecond, because meter, m, simple m, we use for milli also. It's a prefix same symbol we use, so you will get confused. If there is no space, that means it is millisecond. If there is any space, that mean if there is a space, that mean it is meters second. I hope all of you understood these things. We'll come to the next part in the next video. Okay, thank you for watching.